Hey everybody, CT. Happy Halloween. Today we're going to be talking about making a PDDL parser for our planning part for Sokoban. Yeah, so let's get started. Alright, so I realize I can't keep this minimized, so I gotta keep it up if I want the songs to keep playing. Yep, that's all good. I know I have a timer up in here somewhere too. It's probably this thing. Alright, good deal. Since I was wearing a red shirt, I decided to wear my wife's headpiece, which is Amy the Hedgehog. And yeah, alright, let's get it. Let's do it. My mic's a little far from my mouth, so I'm gonna just kind of see if it still hears me. Let's see. Yeah, I think it's hearing me. Alright, good deal. Okay, so we got Unity up, but we're still working on our planning module part, and we gotta work on the PDDL parser, so let's do it. So while that kind of loads up, I'm gonna go ahead and get another Chrome, and we'll just say PDDL, just so you can see what it is. Planning domain definition language. So there we go. It's basically an official language for planning problems, and basically you get a domain description and a problem description, and basically you're supposed to solve a problem within a domain. So yep, just so that you know. Cool. Alright, so Visual Studio should be coming up pretty soon, I think. Hopefully. Maybe. Oh, I see it. Oh, I see the icon. Here we go. So I'm kind of porting, or I am porting the logic my professor did. So I am definitely gonna pull that up too. Something that's totally irrelevant. I'm gonna hide that. Yep, that's what I feared. Let's see, hourly. Yeah, it's pretty good all day until like 5 o'clock. Cool. Alright, so I'm going to take some of this code and put it into C#. So here we go. Let's go ahead and what I might do is I might just grab it and paste it and see what happens. So I'm going to go to IO, Parser. This one's a big class, so alright, so we got that, and then everything inside, which we already kind of have, but I'm going to go ahead and do it myself. There we go. Alright, so where we see final, I think it's safe to just put read only. And I could just do the replace function, which I think I will do. So final, read only, replace next. Okay, so that's cool. Where we have the capital string, I think I'm gonna make it lowercase string, just cause I think C# has a preliminary definition for string, so you don't have to use the using statements at the top. Okay. I'm just gonna go through the whole code and do it. Yep, string. Uh-oh. I saw I already screwed up one string. Oh, well, it's already lowercase, so it's okay. Cool. So that all looks good. Control KD. That all makes it nice and good. Ba, 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 ba. Okay, so what are we doing here? I see a bunch of wrong code, but I'm going to try to get into the meat of it right quick, which is the parse function. So here's one of the parse functions. Okay, so how generics work in C# is you just declare the generic, I think. Oh wait, well first you need to say that this is going to be a generic class, right? So we're going to have to say, specify the generic right there. So we do it usually by the letter T. And then you just say, hey, this is going to be a T. Oh wait, no, void. I think you could just say T. I don't remember. Oh, I think this is where I specified the T. Then I'll have to do this. And do I just say T here? I'll figure it out. I don't think I want to do the T there. So you could just be a new parser. That's not what I wanted to specify anyway. Ah, here we go. Parse. Let's just say I wanted to parse a file of type T. Yep. I'm going to delete this. Delete that. I'm going to comment out all of this for now, just so I can work here. So public void, or do I return to T? Oh, maybe I return to T. Public T, parse T, file. Okay, so instead of file, oh yeah, sure, file. Oh, this is going to actually be a stream reader, because I'm going to replace file with stream reader. And basically it's just saying, hey, parse the file. Oh, the node's going to parse the file. So now we got to look at node, and I'm probably going to just pass in the type again. And we won't need that. So something like that. So that seems good, but we need to actually get to that file. Or maybe it doesn't even exist.
Sorry, I did.
Cortana, no! It doesn't contain the definition. So we're going to go to node. I am actually just going to go and copy and paste the same code. So this is our detour. And I'm just going to copy all this code from node straight into here. Oh man, node's a huge one too. So yep, that's why I'm glad we are just doing this episode. So yeah, all of this for now is just going to be this. Cool. Alright, so this is going to be read only. Control KD. When you create a node, it's going to be the next node. Okay. Right now I'm just converting the booleans to bool and the instance ofs to is. Yeah, so luckily this is kind of a very base class, so all these conversions are pretty easy, luckily. List. Is list like... Test if this node is a list. Oh, so we actually have a list object. Alright, well, we're gonna have to make a new object. Call list. Generate a new object. And another detour. Woot woot. Alright, good deal. Let's go ahead and port this. Read only. Raid only. Read only. Read only. So instead of super, it's base. If this is a constructor, we just do it here. I think we just gotta use system here. Okay, so simple enough. We just say public override. Make this a lowercase and make this a capital case. Not bad. Boolean. What? This has first. Is first like oh yeah. It's a node, right? What's wrong with it? Declaration of local variable hides list.first. Cannot use local value first before it's declared. So it's kind of like two different things. You shouldn't really call this bool first, right? It should just be I'm gonna take this and let's just make it like is first or something. And then we can say this is first. And then something like that. Ah, yeah. Okay, something like that. I think that's good. Control KD. I don't think there's any errors in this one. Good. Oh, wait, yeah. What do we say? Oh, we're not actually extending any classes? What were you extending? Oh, list, oh, list. A list is a type of node. So, like this. Is node not super public? Yeah. Node is inaccessible due to its protection level. Oh, due to my protection level? Like, do I have to say public list? Oh, and then of course here, we're node. Could be at least protected, but I'll do public. Okay. List is done, so we can go with a node. Node seems to be getting there. Alright, so static read only open and static read only close. I don't know what intern is. Intern. Is that like a function down below? What I like about Eclipse, and I wonder if Visual Studio has the same thing as this like outline view of all the functions. I really like that. Let's see, is there a, it'd be under view. Start page, toolbox, find results. I don't think it'd be necessarily a toolbar, maybe like an other window. History, pending changes, code metrics, find results, notifications, toolbox, task list, start page, output, error list, object browser, code definition window, call hierarchy. One of these suckers. Let's try code definition window. And no, I'm gonna close this. or hide that. Can I just click this? Would that close everything? Okay, no, just close that. View, class view. Pretty good. I mean, I like it. That gives you kind of the hierarchy. That's pretty cool. Invalid global type, huh? Oh, cool. It gives you. All right, let's I closed out the properties. Let's just click with this. So I'm on node. So let's go ahead and see what node got. Nice. All right. So not bad. Not bad. But I don't see. I don't even see any of these functions. Oh well. Whatevs. Oh. Oh, here it is. Here it is. My bad, my bad. Yeah, that's all good. So we got close. We should have that open and close. Yeah. Intern. Do you see that function? Is that in here? No. What is intern? What is intern? What if I go to the Eclipse and see what it is here? So where I see open and close on the node. Oh, I gotta go to node file. Go to intern. I'll bring it here just so you can see what I'm seeing. Intern. Where's intern? Here we go. So if I F3 this. I don't know. What is the intern function? Represents text as a series of Unicode characters. That's what this does? Oh wait, I'm looking at the wrong. I'm like, yeah, duh. But let's see. Let's use our favorites. Intern Java string. What's that do? It's supposed to return the string from the string pool if the string is found in the string pool. Otherwise, a new string object will be added in the string pool. Okay, so it's basically to do some equaling or something. I'm going to take it out for now, and I'm sure that will lead to some errors. But for now, a means of iterating through a set of tokens similar to the iterator. Okay. Cannot declare instance member in static. Okay, so even though you're static, everything else has to be called static. Alright, so we got current and IEnumerable. Token iterator is going to take a list of strings. You're going to be also static. I think static should be first anyway. I don't know how the rest of the code is, but whether it's instance or static, I think it's always the first thing you should know before it's public, private, or whatever. can just say it like this, right? What don't you like about that? Oh, it doesn't like this because you're static. Token iterator. Yeah. I'm gonna say tokens like that sounds good. Token iterator dot tokens has next. Token iterator dot tokens. Let's see, get type, move next. Advances the enumerator to the next element of the collection. I agree with that. How do I see if they have current? Gets the element at the current position. Oh, okay. I got it. I see what you're saying. It's similar. It's very similar. What does get enumerator? Yeah, it's returned. So this should be okay, right? Get enumerator. What cannot list strings to I enumerable. Cannot implicitly convert type list string enumerator to. Oh, really? Well, can you just give me whatever kind of enumerator you should be? Like, if I don't say you're an enumerable, I just say you're like an enumerator, enumerable. The non-generic type enumerable cannot be used with type arguments. There we go. Phew, I couldn't get it. So, there's an enumerable and an enumerator, so make sure it's enumerator. Okay, so we're gonna say, hey, if you move next. I think we just say current, right? So current equals tokens dot current. I think that's right. I really don't know how that works. And it'd be great to I just realized what this was doing. A static real-only field cannot be assigned. Yeah, this is just a I don't even know how to call this. Static token iterator? Static constructor must be parameterless. Oh. Static void. Static public void. Create token iterator. Yeah, I don't know how that works in Java, but I won't ask. Static read-only field can only be assigned to... Yeah, I'm not really convinced that this should be a static class. I just don't know. Okay. So I'm gonna have token iterator, but it's not gonna do anything. Yeah, let's just make this the yeah, there's no way, right? Unless I don't make you... Wait, a static field cannot be assigned except a static read-only field, which I don't think you are. Yeah, you are. Alright, private. I took out the read-only. Tokens.getEnumerator. Alright, so next we'll just say, hey, tokens.moveNext. And if you're okay, then just assign this to tokens.current. And so all of that. Is this legit? We need this just because of the way this is, because of that. So tokens, awesome. Read only, you can return a node. I guess I'm gonna just make you a stream reader file. Yeah, this is all news to me. Okay, slowly but surely I will try to get this right. List string tokens equals new list. String tokenizer. Erg, I don't know. String tokenizer Java in C#. Okay. Interesting. So we're not using tokenizer anymore. We're gonna use split. Sigh. Yeah, I have no idea. Let's read to end. What do you return? A string. Okay, cool. String. File data or file string equals file read to end. Okay, so basically we get all the file. Just like this string token. Uh-oh. Is that me? Yeah, alright. So, what are we doing? Oh wait, I got some people in here. Sorry, I didn't even see this. Nanathaj, man, I'm sorry I didn't see you here. Let me read what you said, dude. I don't know how long ago you were talking to me. You can set it to equal, list implements I enumerable. Yeah, okay. Though it's being read-only stops you from doing so. Mind if I ask what program you're using to overlay? Are your tokens already in an enumerable? Why not just use the build enumerator to iterate over them? Yeah, that's what I'm trying to do. As enumerable is a sequence of items that can be enumerated. As enumerator, it is an edit. Right. So the enumerable is the basically the contents of each thing in enumerator, right, or something like that. Is a sequence of items that can be enumerated. And the oh, okay. So the enumerable is the data structure, and enumerator is the kind of iterated through the enumerable. Got it. On board. On board. And hi, Nanathaj, man. Dude, I didn't have my chat up, so I didn't see any of this. And you're probably not even in here anymore, huh? Oh yeah, you're here. Cool. What am I using to overlay? I'm using OBS. So I just got OBS. The bottom left is my task manager. You know, just the default little graphs in task manager. Stream time, just some clock timer I got. And I'm using the night dev site or something for the chat up there. So all OBS. Here, I'll even show you. So this is it. So yeah, the camera, that's me. The Twitch alerts, you know, shows if someone's following or something. Now playing is this white bar here. Stream title is this. Twitch chat is this chat window, and it's just like an HTML file. Timer is this thing. Ethernet memory, CPU usage is all of these things, and it's just getting it from my task manager. The monitor capture is obviously the main thing, and image 2 is just an image I made of this like bar that overlays over it, so it's just an image, which I think I got on my desktop, maybe. Stream interface, something like this. It could be this one. Open it up, and gosh, I'd like Windows Fax Viewer. Oh well, I'll put it in Paint. So here it is, yeah. And so this is just the image I'm using to overlay. Hope that answers it. Back to programming. Yeah, no problem, man. Alright, so yeah, I'm porting code, dude. So that's what I'm really doing. This is Java code that I'm trying to port over to C# so I can use in Unity, because I want to make a visual for a planner. So yeah, so I'm making this PDDL parser, but I'm kind of noob-ish on everything in C#, so I'm trying to learn how to do some of this stuff. So what I just learned is that tokenizer in Java actually is trying to be deprecated to the java.split. So I'm going to try to convert this code into using a split of the string, and I'll try to also keep track of the chat, just so in case I miss something, I can just be like, oh yeah, chat. Maybe you guys can help me out. So thanks, man. Alright, so I'm not going to get a list of tokens, because let me see what we're doing. We're getting the tokenizer, we're reading all the bytes, we are looking for these kind of characters, and I don't even know how the tokenizer works. But basically, I guess you just kind of iterate through the tokenizer until you're done. So, okay, if I just said file string.split, what are my options? Separator and count, separator and string split options, separator and Morse, a character array, a string array, a character array, count and options, string. Okay, so I definitely know that file string is what we'll be using, so that's pretty easy. Now from here, which ones do I use? What kind of string split options do I have? String split options dot what? Remove empty entries. Ah, interesting. Oh, duh, it's not file strings. I'm an idiot. Let's just try using what my professor used. I don't know what these are. I guess parentheses as well. Okay, cool. So that kind of does all of this code, I'm guessing. Better look at what's happening. I'm about to delete all this and I'm probably going to regret it. Okay, so we're getting a tokenizer. We're going through all the bytes. Okay, Nanotage says that will split on that sequence. You'll probably have to call the split for each of those separately. Oh, okay. Because, alright, so what I see right now, it's reading all the bytes from the file. So it basically makes it a new string. So that's cool. That's your entire file in a one string, which is cool. So this actually has a space, /tab, /return line, /new line, I forgot what F is, and parentheses, right? So, okay. As we go through our tokenizer, it's going to trim it, so trim all the white space off of it. If the token isn't empty, we're going to add it to our token array. Yeah. And so that's all this does, right? It's just it keeps adding everything to our token array. So that's kind of just like the split here, I guess, right? So this is going to make it an array of all things between these characters, right? And so, yeah, those are just, yeah, that's what I'm guessing. Those are the characters for the tokenizer. So, okay, once the tokenizer is done, what it's going to do is make a token iterator over tokens, and then return that token iterator to parse node. And then we got to look at parse node code. But once the token iterator.current is equal to close, if I'm here and the token iterator is the close parentheses, like, hey, there's a problem. Otherwise, you can return the node. All right, I think I understand. It's all very recursive, I see. But then it makes a new token iterator, which is this class, right? And then it's just going to pass tokens. And when you pass tokens in here, man, my mind is kind of getting blown right here. There's so much recursion. It's like, I don't know. But I'm going to see what happens. I'm going to replace this with this. And, sure, we'll call it, where's tokens? Tokens is, can I just say tokens equals this? Will you kill me? Represents a text series of Unicode characters to, alright. Wait, man, what are you telling me? Oh, it has to be an array. I gotcha, no problem. I can make him an array. I don't have to do it just one like that. So we can just say character, and then we just say what we want. New character, an array of these guys. And then basically we want the space, we want the tab, we want the read, we want the new line, we want the /f, which I don't remember what that is, and then we want this. I think that's all. Nothaj says, hey, splitting a string based on multiple character delimiters. Yeah, that was an array. Yeah, the array was what the link was. Oh, yeah, gotcha. So I'm gonna make a new character array. This, and this. Am I doing that wrong? Oh, character array. Do single quotes. Single quotes for characters, people. Double quotes for strings. There we go. So there we go. We're gonna split this into that. I figure it's just gonna return a what? A string array. Tokens doesn't exist here for some reason. Tokens is what's tokens? It should be like an enumerator, right? Of string. Token. Oh, we're outside of the token iterator thing. So this is just going to be a string array. Bam. That's a long line. Okay. Cool. So far that's good. I'd rather not make a new token iterator if I don't have to, since I'm not using token iterators. Can I just make this an iterator? I mean an enumerable. So I just say, hey, tokens dot enumerable get enumerator, and just say, hey, I enumerator of string is ti, and just pass that into parse. Ah, yeah, okay. What did I do wrong? Token iterator tokens. Let's see, F12 to go here. I don't want to make it a token iterator. I just want you to be an I enumerator of string. Okay. That seems fine. Oh, what did I do wrong here? Tokens dot get enumerator. Oh, is there like a option here? Tokens is a string array. I enumerator is an enumerator over strings, but it's saying that system collections I enumerator to systems connect generic I enumerator string. So what, you just want me to say don't do this? Yeah, you're not a thing, right? I enumerator string. Yeah, come on, man. What don't you like about me? Oh, because it's not a generics. The way I could handle this, and just the lazy way, which I'm all for it, is, can I just do that? No. I mean, I get what it's saying. It's like there's an enumerator for a regular array and there's an enumerator for these generics. Yeah, I gotcha. I gotcha, Nanathaj. I need to either, I can convert this to, I'm just doing it. Screw it. Class, string, list string, I don't even know. This is just going to be all wrong, but this is how I'm going to do it. New list strings. Can I add just an array in here? Awesome. Tokens dot get enumerator. Done. Alright, cool. So now it is an enumerator, and I just basically converted that array to a list, and we got the enumerator from there, and then now we passed it here. Awesome. Yeah, I guess I could have. I like to make the compiler happy. And I know casting it would have made the compiler happy. I don't exactly know the magic between the array enumerator and the generics enumerator, and I'm not sure if there's any kind of difference, so I figure I'd just make a generics list array and call it a day. Alright, so parse node is taking the I enumerator, which that should be fine. Oh, but now it doesn't return a node because this should be read-only instead of final. That's the C# version of final. And ti.current, I think current is going to be the capital C equals close, and you can throw an IO exception. Otherwise, go ahead and return node. Cool. Porting code is fun. It's fun for everybody. Alright, so read only. We had a parse node function who doesn't return what they're supposed to return, I guess. Oh, you can't read only this or something. The modify read only is not valid for this item. Okay. Doesn't have to be. I don't care. Maybe whoever programmed this initially cared. Nom, 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 nom. I think you're called move next. Oh. Wait, what were you? You're next, right? But how do you know there's a next? You don't. I'm gonna have to do something here. To move it to next and then return next. Tokens dot move next, and then we return current. Because there is no like get next, right? It's just move next, then current, right? It's not liking it, so it probably isn't right. Parse list. Oh yeah, I see. Interesting. I'll get back to it. That's fine. Parse symbols. Okay, now let's just look at right quick at the rest of this stuff. I enumerator. Let's get rid of these token iterators and just make these string iterators. Okay, so it's definitely not. I think it's just like this, right? Like I just move next and then return tokens. Tokens is an I enumerator string. What don't you like? Oh yeah, all of this junk. You're gonna return a list. Oh yeah, list is a type of node. Sorry, it's I don't like that because it's kind of conflicting with the C# stuff. All right, it's going. We're getting there. We're gonna say move next, and then current. All right, so that function's done. Tokens that current. You're gonna just move next. Current. Symbol is having a trouble, but we'll come back to that. What is wrong with you? Read only? You don't like the read only? Okay, I don't care. Oh, can't use this thing. I'd rather have this thing. Oh. Crap. Yeah, I see it. Oh, I'm kind of getting rid of this, right? I should have been using token iterator. I thought token iterator was another class I had to make, but apparently I've implemented this already. MFer. Now I don't know what to do. Ah, shoot. I mean, I think I'm doing just fine with that. I'm deleting it. Sorry for wasting our time on that. Alright, so parse. What does parse do? Yep, gets the file string, makes an iterator, It doesn't have to be called a token iterator. Oh, yeah, Nanataj, man. Go work on homework, dude. I know this is totally a boring one, but yeah, man, thanks for stopping by, for sure. Good luck on your homework, too. That's kind of what I'm doing right now, right? Is homework. Because this is kind of a mix between my classwork and my game. So yeah, good deal, good deal. Alright, parse. So what am I doing? What am I doing? Okay. So parsing, sorry, I just lost track of thought. File string, tokens, yep, we iterate through it. If we somehow end it on the close, we entered, you got errored way too soon, but then you should just parse node. Sorry, parse node, what do? You take the token, you say, hey, if the current's equal null, then return null. If the current is equal to open, you just go to the next, and then you parse list. I'll just leave it open. Okay. If you find the close, you weren't able to even start the list. I understand that. And then here we go, parsing the list. If it's equal to null, you encounter the end of the file before. Yup. I gotcha. What do you have wrong? Inaccessible due to your protection level. I understand. Okay. Let's build this. Just see what happens. Sure. Oh yeah. So we finished a node, but we haven't actually finished this parser. So okay, the parser. Back to the parser. I'm looking for the new nodes. Oh, new list. Yeah, here we go. Okay, cool. So list, or you're either a node or you're a list, right? So, and parse symbol. Nice. Okay, I think I understand. We don't actually need to do this. But we will have to do this. Oh, don't worry. That's what this next thing is for. So that's parsing the file, this is parsing the node. And this should be pretty close to, so that's a T, we'll have the generic T. There we go, so now that's all matching. I'm not going to do any of this not check stuff. Alright, so if node equals null, return null. Oh well. Yeah, I don't know how to return null in the generic sense. I need help. Google, C#, return null, generic. Oh, default. Nice. Nice. Default T. Sweet. That's how you do it. I'm not gonna get a parser. Yeah, we're not doing any of that. Not doing any of that. What are we doing here? Maybe we are doing some of that. What are we doing? Alright, we gotta do different kinds of parsings. Hey, I gotta take a quick break. I will be back in just a second. So let me see, time, we're at 55. Alright, yeah, I'm gonna take a quick break. I'll be back in a few moments. Maybe I'll just leave it streaming, but I'm gonna, yeah, I think I'll just leave it streaming. Be right back. Hey, I'm back. Alright. Um, okay, so what have we been doing? Looking through a lot of junk, really. Alright, so when we're parsing, we are saying what? If the node is null, that's fine. We're just going to return null. But if the node isn't null, we're going to grab a certain kind of parser. So based on that first parsing, we're going to figure out what parser to use. And I don't know how we're going to... Oh, there we go. How do we get type? Oh, yeah. So... yeah, I see what we're doing here. So we got a domain parse. Hope I didn't delete any of this stuff yet. Yeesh, okay. Let's work our way back from the beginning just a little bit, because we commented a lot of this stuff out. So all this, we're gonna put it back. Control KU. Okay, so instead of a hash map, we're gonna make this a dictionary. And we're gonna make this a type. And we're gonna make you an object parser of something. An object parser, is that one of our Eclipse functions? Where's Eclipse? Here it is. Yep, object parser is one of our Eclipse functions. So I'm just going to grab the entire thing. Let's go back to our just regular view. Let's see what happens if I say generate class object parser in here. And just for now, I'll just paste it up in here. Oops. In these brackets. Alright, so we can get rid of this. So, yep. It's an interface. That's okay. I don't know why I'm forcing this to T, but that's kind of what you like to use. Parser is... oh, PDDL parser is what we call it. Oh, we don't have to make this public, is what you're saying. Okay, so we have this interface. Yeah, I really don't know. Do I just make it T? But that's the thing, if we already know that this is going to be a PDL parser of type T, we don't know. Can we make like unsure? Generic, unspecified variable. That's the thing, if I don't know... I don't know. How do I... yeah, I don't know. Might have to redo that just because I don't know exactly how that all works. MF, oh, they started fire. I don't know. It's a shame. I should know, but I don't. But I know what's kind of happening here, so we'll have to just sort of swing it that way. Yeah. Maybe I'll leave it there for now. I'll leave these here. I'll tab these over till I figure it all out. And then I'll just comment it out. Alright, good enough for now. Oh, and you should be a PDDL parser. Alright, good. Type of T parser. Oh, did we just delete it? Oh, okay, never mind then. I shouldn't have deleted it though. We should, let me get parser right quick. I'm just comment it out. I just, don't know exactly how to do these. So, it'll be okay without it. What do you want? Protected void. Method must have a return type. It does, right? Anyway, I'm done. This I'm okay with. Object parser. I don't even know what's happening here. Alright, so you're going to pass the type. You're going to get an object parser of that type. Oh, I think I'm understanding finally. So we have basically, let me go back to class view, and we're at node. I guess the way I would have handled this is I would have had object parser. How would I have done this? Like subclasses, I guess. Like basically the main class would have parse and everyone would override that parse function. So let me see if I can kind of do that here. So I'm kind of like just ignoring all of this for now. So going down, I'm not really doing any of this. Alright, so I'm kind of commenting that out. That's okay. Alright, I'm getting there. So require, that's all normal. This is where I want to go. Parse domains and all of this. So this is how I think I would handle it. I'll have like parser, type parser or something. And then okay, type parser, public. I'll think of it. I'll think of it. This is how I'm gonna handle it. Type parser, type. Public static create parser type, and I like to mix up the static and the public here. Alright, so here we go. We got type parser, create parser of type, and then I'm just gonna make it a switch. Type, and then I'm gonna say, hey, case type of domain, return new domain parser, and then basically just kind of do that all the way through. Okay, so you don't like it to do it like that. That's okay. If type equals type of domain, then return, almost like this one better anyway. And then anyway, class domain parser extends type parser. And the only thing you have special in here is you have a public domain parse node, basically this code. And this will help because we don't have that covariance, we don't have the covariance of type, so you can actually, this will actually work. Whereas some of the other ones may not. Trying to figure out the ends here. I feel like this is correct. It just doesn't know, I guess. Not yet. We'll figure it out. So I am going to sort of do it this way. Return new to. We'll figure it out from here. Okay. And let's see what happens here. Whew. Okay, so we have this parse function. This will have a PDDL parse. Create parser should, okay. If nothing happens, we're just going to return a new type parser. And if you try to parse with this kind of guy, new, or here, public, object, parse, node, PDDL parser. All you're going to do is just return null. Something like that, right? And then you're going to be like, what? That's okay. Can I override, or are you going to make me... That's okay. I'll mark you virtual. So you're basically telling me I have to... Alright, I see where this all went wrong. Should have just made this T. Nom, nom, nom. If T equals type of domain, is that right? Or is it just T equals domain? Yeah, I think it's type of domain, or type of T equals type of domain. Yeah, something like that, right? Yeah, I like that. Alright, so that's good. Oh, good. And then instead of object, we can just say T, right? Oh, awesome. And then you say default of T. Okay, and then we can just say, hey, return domain. Oh, good, and it's not yelling at me or anything. Love it a lot. Parser? What's parser? Parser is PDL parser. Oh, okay. When we parse all the way up here, you should be returning a type of, oh, constant. So let me see, do I have, yeah, we have a constant array, so let's go ahead and make sure we definitely get him in here. Parser define all, I'm sure that's a function that we're going to be doing later. We have a list of operators, which is not existing yet, I guess. We're getting there, we're getting there. We're doing the hard part. We're on domain right now. Operator is something in the planning domain that we didn't do, I guess. So planning has an operator function. Okay, so let's go ahead and make a new in here. Maybe I'll just do it here. Under planning, private operator something. And we're not actually going to do that. But now we got an operator file. I can copy all of this, put it right up in here. And I don't have to worry about all these imports right now. Alright, so what are we doing here? We're definitely going to have a read-only string name. Read-only immutable array. And variable. Is variable also part of this? Yeah, no. I think it's under logic. Yeah. So logic, we're missing some stuff, yo. Oh, no, we're not. Use it. Read-only expression precondition. What's going on? Oh, one of these is not very accessible. Cool. Okay, and then the effect. So we get some stuff. I think we just take out the word illegal here. And don't forget to use system. And we'll just keep going. I think this just goes here. And we gotta say what kind of. Okay. Boolean. We're gonna change these instance of to is's. Same thing here. My mouse kind of died. Yep, it's gonna be a for each n. Another is. Alright. What do you want? You don't like the read only? Maybe sealed? I don't know. I was trying to help, but it didn't really help. Alright, so variable in. I think we'll get to that in just a second. Step doesn't have this constructor, I guess. Alright. Override. And it's going to be a capital 2 string. And we just say for each parameter and parameters, do whatever you gotta do. Okay, so parameter is a what? I wasn't even paying attention. A variable. Okay, so yeah, variable we haven't defined yet. Okay, so we're kind of going down this nest again, so we gotta do the term first, and that's what we'll do first. Okay, and so we see this implements formula, so we'll just do it like that. It's going to be a read-only. This is going to be a read-only. I like to make these strings with the lowercase s in case, so we don't have to use the includings. Formula. Oh, yeah, I'll work on that. Let me just hurry up and do this first. I don't think we're doing hash code stuff yet. Okay. Whoa. Yeah, we're overriding some stuff, so let's just keep doing that. Bool. So this is what we're going to do. Type of me equals type of other term. And then type equals other type. So a lot of things. Oh, maybe I did this wrong. Yeah, I did. Cool. I'm not doing the hash code, I think. Override toString public Oh, we gotta get into the bindings too. So much to do. And what are we actually missing here? Do the rest abstractly if you don't mind. What's your problem? Okay. This unify and set equals. I don't know how we have bindings. Binding is not even there yet. So let's go ahead and get this one going too. Wait, what's substitution? I think we gotta do substitution first. Yeah, maybe. I think you're just gonna say get rid of the public. You're not going to be able to do that in an interface. Um, I know this is just an interface, but I might just make this. Yeah, this cause I don't know. Security first, I guess, always. Safety first. Public abstract term get. And you're gonna be like, you're not supposed to specify all of that. Alright, let's see. Can you put a class in an interface or like a static? Public static class. Substitution empty. Interfaces cannot declare types. Okay. Fine. Yeah, I really don't know how this is gonna roll, but I am going to do it for sure. Okay, so what we're gonna say is just return term. What don't you like? Am I not interfacing something? Yeah, I don't know. I'm thinking this is right. Um... Empty, empty. Get return new empty. Return empty dot instance. Something like that. Static public instance or better yet, not even that. Static empty instance get return instance equals null. Instance equals new empty. Or instance. Oops. What am I doing wrong? An object reference is required. Oh yeah, this should be static. Love it. Alright, that looks pretty good. This is kind of a singleton, right? And I know you're going to be like, you can't do that. Do you? I don't see it. Oh, is that what this is? But you can't, right? So I gotta move you out of here. We better call this like empty A or something. empty substitution empty Oh, you can't have a definition. Okay. Oh well, I tried. The only other way to do this is if I made this an abstract class. And then this would be a lot easier. And anyway, you could just be public abstract term. Yeah, this would have been the better way to do it anyway. Public substitution empty equals new substitution I could almost just throw this up in there too, I think. I might have to. So what am I going to do? I'm going to say public static class. Let's call this empty. Empty substitution. Public static class substitution, empty substitution. Okay, whatever. No, I need you to be part of substitution. I guess you don't need to. Alright, public static class empty. Alright, you don't even have to be that. Alright, class empty substitution. Yeah, alright, I'm getting it. There's a way to do all this. Class empty, no Cortana. Got her. Got her before she yelled at me. Alright, so we don't need to do any of that. We don't need to do any of this. So what are you yelling at me? Alright, that's okay. We're about to fix that right now. What don't you like here? Yeah, that's what I'm doing right now. Alright, a new empty. And that's it? Awesome. That's how you do it. A one-time use empty substitution class. And basically I only use it for empty. Okay, looking good. Yeah, and you can't do that here, so maybe... But you can't really say new bindings either, right? So, I don't know. Yep, those two aren't valid here, so we're just going to say bindings empty, public extract abstract. Well, maybe you're not a interface. What about that? In that case, you can do whatever you want to do. Yeah, I'm getting kind of tired with like the substitutions and the abstract classes kind of being similar but not exactly the same. Abstract classes for now are just more featureful, so that's how we're going to handle it. Alright, so shoot, now we gotta do hash bindings. Let's do it. Is it in logic? It is in logic. Cool. see how much or how little work we have to do here. Oops. Record it. Yeah. What, you don't like that? Hash bindings. Oh, we got stuff to do, it says. Let's go ahead and use a dictionary. You know what that is? Just do that. A hash var set, which I guess is in here. Okay. This is where I think we override. I think you're handling it like this. That's the variable. We didn't implement that yet. Okay, let's dig down this rabbit hole. Variable. We'll get there. Okay. I was just seeing. Alright, we are slowly but surely getting through this. I think that's it. Nice. Alright. Good deal. Alright. I'm missing something that says. What are we missing? Yeah, just implement it. See what functions jump in. Can we just do base dot compare to other? Oh, gotcha. Well, huh. Oh wow, we're still going too, huh? Hey stream. I haven't been looking at the chats or anything. Hey Keyard man, I'm sorry I missed you and I haven't looked. What I'm doing is I'm porting some code from Java to C# and the code that I'm porting is planning engine. So basically you put a problem in PDDL, which is problem domain language definition logic or something. And anyway, you put a if you could put this, if you could put your problem in this format, you can solve the problem. So it's kind of like an abstraction of problem solving. So it doesn't have to be for a specific game or specific anything. As long as you put the program in a certain language, you can solve that problem. So it's pretty cool, but there's a lot of conversion I gotta do. And I know I'm just doing this on the stream, it's super boring and not really fun to watch, but I think it will pay off tenfold once I'm done implementing it in C#. And so if I'm using Unity, it'll be great. So alright, so yeah, if you're not even here anymore, sorry man, but hey. Nice hat, ha ha ha. Alright, jeez, where am I? So variables done, terms done, I think. But then to get term done, you have to get bindings done. But bindings is having some issues with can I override? Would that be a thing? Hides inherited substitution.empty. What if I made you virtual? I don't know. I'll just leave it like that. Alright, well let me try something first. First, I want you to be a static. So you definitely need to be static public substitution empty. So that is, for this child, empty is the substitution. Now if we go to bindings, this static public override read only, but you can't override it is what you're trying to tell me. I can make it a new, but what if I really did want to override it? Like, what if I wanted to say, oh, but you wouldn't be a you would be a substitution, right? Static public, but you won't let me do virtual. Oh well. I'm gonna just hide it then. I don't know what else to do. Okay. That looks good. I think that all looks great. What are we gonna do from here? Try to get these hash bindings working, right? Alright, so protected bindings. Term is okay. Where's my hash bindings? Hash var set is not okay. bindings. Okay, cool for now. Get constant, so we gotta work on variable, so that's where we're on next. Get constant should be something in here. Huh, it's not. So let's go to our Eclipse. Variable, or actually hash bindings. You say, I only hear what I want to. Let's see, hash bindings. Get constant. Where do you lead me? Hash var set. Gotcha. Gotcha. Oh man, there's a lot of code in this bindings thing that I don't even know if I need right now. So you know what I'm gonna do? Just because I'm not sure if I need it right now, I'm just gonna go ahead and generate the method and hopefully it never gets called. Oh, but you're gonna need something. Why are you angry? You should return something. Cannot implicitly convert type planning logic constant to logic term. Oh yeah. But constant is a type of term. Oh, we didn't do that, did we? Constant, please. Did we not do constant? Come on, we gotta do the constant and the variable. That's the two easy ones. We gotta do it. Alright, so here we go. Public constant. Alright, so here we go. Constant term, blah blah blah, blah blah blah. So instead of super, we just say base. Instead of that, we just put this. Alright. Okay. These are overrides. What the deal? No, it's got to be just a type of term. Okay. Did we miss something? Compare to, yeah. Oh. So term extends formula. Do you have a compare to? How about the original, which is formula? Yeah, that's what we need to do. At the next level, at this level, if you don't mind, you should have the compare to function up in here. Compare to. Yeah, we just named it abstract, but we really should do it this way. We just say toString dot compare to other dot toString. I think that's how the other one did it. Yep. Oh, and return. My bad. Sharona. I don't know. Why don't you like that? toString. Oh. Like that, right? You are a function, so you must have parentheses. There we go. That's what we needed to do. Alright. And then hopefully now variable doesn't need this. and neither does constant. Constant. That was my bad. Okay, so that looks pretty good. So we got constant, variable, term, hash var sets, hash bindings, where that's okay now. You just need to override. You need to just say is. Cool. And this is all taking form. Oh lordy, is this a hash var set? I don't know what this means or does. So we're just going to generate some methods here. Oh man. Oh, we know this one. This one could just be contains key. Bindings. Yeah, that should be okay. And slowly but surely we're getting there. Oof, a lot of conversions, a lot of fun. Phew, alright, a lot of code, getting through it. At least it's not too different, like the code's not like a whole another language, you know, it's just a few syntactical things from here and there. I mean, it's still enough to be like erg, but I'm gonna go to this function. Oops, I accidentally hit build. I meant to say, no, that's okay. Just trying to get to this function. If you don't mind, just make it a list of something. Constants, how about terms? Phew. This just gets infinitely deep. Well, not infinitely deep, because we're actually getting through it. But, you know. Oh well, I don't care. Let's say hash set. Oh my goodness. Alright, this is just going, huh? This is going on and on. I feel like we're getting to the end. Oh my gosh, is that the end? That took a lot. Oh man. This thing is just so big. And I'm trying to do it in a matter of hours, which is probably not realistic. But I refuse to believe it. So I just keep going. Alright, where am I? Who am I? I don't know anymore. I think I'm working on some special class somewhere. Right? Do all those functions. Parse all these crazy things. So, back to the domain parser, right? So we got operators is going to be a new list of operators. Child. Alright, so operators. Definitely it's going to be an add. Parse, child. Oh, just operator. Oh gosh. Okay, stay calm. It crashed on me. That's dangerous. I don't know where I saved it. It better be okay. Yep, I'm waiting for all the red to come in, but until then, I am, let's say F6. There we go. Should I just close it and open? Oh, it came. Alright. Type parser, that's fine. Define all constants, operator. Okay, yeah, we didn't get too far out. So add, we don't have to do U, but we do have to do operator here. Okay. And list does have a toArray function, but I don't have to do all that crazy stuff in here. I think I just say toArray. And we return a new domain. Wait, why are you angry at me? Oh. Okay. What do you have? Oh, you don't have anything yet. Let's go ahead and make a domain right quick. A domain is a planning object. It has just some things, not too many things. I'm gonna go ahead and do it like this. Domain. Okay. I'll do it as you ask for now. And for sure. And yep. I'm working on it. I'm just working on it. Params, operator.
Are you now?
What are you talking about? I'm gonna guess year of constant, and I'm gonna guess year of operator. Oh, and oh, do I not need these? No, that's okay. That's what I was gonna do. So hash code is a thing, and I've got to do it everywhere. Oh well. I will learn that in a bit. Okay, got the domain. PDDL parser should be happy now, and it is. Cool, so we got the domain working-ish. I mean, we don't know yet. We didn't get to test any of this. That's a whole different thing we gotta do. I'm gonna go up a little bit. Okay. Yeah, there's just too much work to do. I'm gonna take a time out. I'll be back to finish the parser in a bit, probably later tonight. But we're gonna get this done, and we're gonna just knock it out of the park, and it will be wonderful. And we can step on to the next step, which is to actually start building some planners, which is what I really want to do. All right. Sorry. The reason I'm sorry is it's just a lot of code. And a lot of code just means a lot of boring time, but at least for streaming purposes. But I'm still gonna put it up there, because if you're interested at all, or see what I've done or what I've been doing, you can take it step by step, and that's pretty cool, I think. But alright, until next time, which is hopefully tonight, I'll see you guys later. Happy Halloween.